we're going to get some practice applying and deriving the formula for the partial sum of a geometric series. This will obviously be very helpful in preparing for the quiz on Friday. Let's start, and let's say that I have a geometric sequence where I have an initial term, a sub 1, and a common ratio of r. Okay? So each term, let's go ahead and just make a list of the terms. So here's n, and here's going to be a sub n. What I want you to do is pause the video, and for n from 1 to all the way to 3, I want you to write out how I would compute a sub n. All right, so for the first term, it's just going to be a sub 1 times r to the 0, which is just 1. And then I have a sub 1 times r, and then a sub 1 times r squared. And so any term in my geometric sequence, a sub n, can be found by taking a sub 1 and multiplying it by r to the n minus 1 power. This is for n greater than or equal to 1. Okay? And now the series is just adding up all the terms. So the geometric series would just be a sum of all the terms. And we might want to be interested in the partial sum, which we denote as s sub n, where I take the sum of the first n terms. So what I want you to do is write down what that would look like. So you might start out by saying, okay, well, this is just going to be a sub 1 plus a sub 2 all the way up to a sub n. And you can write this in summation notation using sigma, starting with I equals 1, going all the way up to n. I'm going to be adding each term. Now, each term can be found by taking a sub 1 and multiplying it by r to the n minus 1. So I'll have a sub 1 r to the n minus 1. So thinking about it, if I is 1, that's the first term, and that's going to be r to the 0, so it's going to be I minus 1. And so now to expand this all the way out into the form we're used to, right, the first term, or in other words, when I is 1, I just have a sub 1, and then sum says to add, and then I will be 2, so I'll have a sub 1 r to the 1, and then the third term, when I is 3, right, a sub 3 will be r sub 1 r to the 2, all the way out until I get to n, and that will be a sub 1 r to the n minus 1. So what I advise you to do now is to go back and think about how you could find the formula to compute this partial sum, a sub 1 plus a sub 1 times r plus all the way up to a sub 1 times r to the n minus 1. So your first step is to pause the video and go through and actually derive the formula. I'll quickly say the formula, but you should look back in your notes if you have any questions. So the partial sum, this is the partial sum, right? All the terms being added up, and the formula that we get by multiplying by a form of 1 is going to be a sub 1 times r to the n minus 1 over r minus 1. And this is for all r when r is not equal to 1. So r can't be 1. Okay? And so this is our formula. All right, I'm going to give you a couple of problems to try so that you can get some practice. I'll give you the answer, but you should be able to work through them on your own. Here's the first one. So I want you to rewrite this polynomial expression so that it's easier to compute for any value of x. So go ahead and do that. I'll give you a hint. Think about multiplying by a version of 1. Okay, I hope that went well. What you want to think about is, what if I multiply by x minus 1 over x minus 1? And so when I do that and you actually multiply this out, you're going to find that you're going to get terms that cancel. So what are you going to end up with? Well, when you do that, you're going to get x to the 5th minus 1 over x minus 1. And that is going to be easier to compute, but of course this won't work if x is 1. So this is when x is not equal to 1. All right, here is another one to try. So go ahead and pause the video and give this a try. I'm simply going to give you the answer so you can check whether it's correct or not, and then go back and make corrections and see if you can problem solve if you got a different answer. All right, so here are the answers. It makes sense to think that this sum, partial sum, will be smaller because this ratio of negative 2/3 will make every other term negative, right? So if you think about the first term being 3.5 and then you multiply by negative 2/3, that next term is going to be negative. You multiply by another negative 2/3, that term is going to be positive. So half your terms, every other term is going to be negative, so when you add them all up, those negative terms are going to bring your total sum down. Go ahead and pause the video and give this a try. Hopefully that went well. What you want to think about here is that this is another way of writing a partial sum. So this is really the partial sum when n is 17, because here is my initial value a sub 1, and here is my r value. And so what this will look like is the first term will be 5, and then I'll have plus 5 times negative 2 to the 1, plus 5 times negative 2 to the 2, all the way up until 5 times negative 2, negative, to the 16th. Okay? So you can use the partial sum to find that. Go ahead and give that a try, and I'll tell you the answer in just a second. So if you use your partial sum formula, you'll get that the partial sum will be approximately, actually, this is actually going to be exactly equal to 218,455. Okay? All right, hope that went well, and make sure that you put down a comment or a question, and see you guys on Friday.